Good morning, students. In previous lecture, we have done work on exercise, parametric form questions of derivative, and second type we have done, that is 5.7, second derivative of the given function. I have given idea to you to do second derivative in the questions of exercise 5.6. I think you have done the exercise 5.6 and 5.7 both. Parametric forms and derivative, and second is second derivative of the function. Now next you have to do the questions of miscellaneous chapter 5. Miscellaneous questions. In the miscellaneous questions we will discuss few important questions that is on page number 191 of NCERT. You have to open NCERT and we will do today few important questions of exercise, miscellaneous exercise chapter 5. Now open your NCERT. Without NCERT book, without question reading, you can't proceed. It will be difficult for you to do, to understand. I will just write down question now. Miscellaneous exercise. Exercise is miscellaneous exercise. Miscellaneous exercise of chapter 5. Chapter 5. On page number NCERT on page number 191. Okay. Let's do questions. I will do question number 6. Question number 6. Write down the statement of the question number 6. That is, y is equal to cot inverse into under the root 1 plus sin x plus under the root 1 minus sin x, and in denominator it is under the root 1 plus sin x minus under the root 1 minus sin x. Okay, here condition is the value of x will lie in between 0 and pi by 2. This is the condition given. Now here you know very well, suppose it is 1 plus sin x, how to simplify it. I think you can write this statement like this. 1 can be replaced by cos square theta. Here I will take x by 2 because it is a requirement of the question, plus sin square theta, and it is x by 2. 1 can be replaced by cos square theta plus sin square theta. Value of cos square theta plus sin square theta is 1. So that's why I replace this 1 by this statement, plus now formula of sin x is 2 sin x by 2 into cos x by 2. Cos x by 2. If it is minus 1 minus sin x, then what? This 1 is same as, this statement is same as, only sign will be different. So I will write, so it will be clear to you, minus 2 sin x by 2 and cos x by 2. Now it comes. Okay. Now these are the values of the given statement, 1 plus sin x and 1 minus sin x. If I put those values, this statement is, first statement is what? That is cos x by 2 plus sin x by 2 whole square. You can see here a square plus b square plus 2ab. And this is also a square plus b square minus 2ab. It means this will be cos x by 2 minus sin x by 2 whole square, a minus b whole square. If I put the value here in this question, then what you will get? Y is equal to cot inverse, here when you put 1 plus sin x at the place, this you put a cos x by 2 plus sin x by 2 square. Square and root are cancelled. Now I have to write down direct. Cos x by 2 plus sin x by 2. Plus, if you put statement here 1 minus sin x, the cos x by 2 minus sin x by 2 whole square cancelled by the root, then you will get cos x by 2 minus sin x by 2. In the denominator, what you will get? Cos x by 2 plus sin x by 2. Here is minus sign. It means you have to change the sign of the further statement. That is cos x by 2 plus sin x by 2. Now what is now solution? This is cancelled terms. Here cos is cancelled. What you are getting? Cot inverse 2 cos x by 2 upon 2 sin x by 2. 2 cancelled. What you are getting? Cot inverse inside cot x by 2. As you know that inverse trigonometry, that is what? Y is equal to only x by 2. Here is the part further. Up to this part you have done in the inverse trigonometry. Now further is what? You have to differentiate the function y is equal to x by 2 with respect to x. Now differentiate the function, differentiate with respect to x. What you will get? Y dash, or you can say dy upon dx. Both are the same notations for the derivative of the function. Taking 1 by 2 outside, the derivative of x is 1. So what? Y dash is equal to 1. This is the answer of the question number 6. Hope so. You can do this question. The next question we will do, that is question number, let's do question number 9. Question number 9. Write down the statement of the question number 9. Question number 9 is, y is equal to sin x minus cos x whole power sin x minus cos x. Sin x minus cos x. This is the statement. You have to differentiate it. Differentiate with respect to x. Now if you differentiate with respect to x, differentiate with respect to x, you have to differentiate it. Now here you can observe this is the type. Which type? Variable to the power variable. If this type came in the exam, then you will do question by taking log. It means taking log, take place, taking log. Taking log means just take the log. If you are doing question log with me, then do the question. Start. Taking log. Taking log means question becomes log y is equal to sin x minus cos x log of sin x minus cos x. Which formula we have applied? Log m to the power n. Then n comes first and log n. Now differentiate it now. Differentiate the function with respect to x. This is the first function, this is the second function. It means two functions product is given to you. Apply u into v algebra. Now it is 1 upon y dy upon dx is equal to, suppose sin x minus cos x is as it is. Sin x minus cos x is as it is. Differentiate log t. Log t means 1 upon t and derivative of t. Derivative of t is what? Sin x minus cos x. Sin x derivative is cos x and cos x derivative is minus sin x. So that's why it is cos x plus sin x. Plus sign. Now log of Sin x minus cos x is as it is. The derivative of sin x minus cos x, that is cos x plus sin x. Now you can see here these two terms are cancelled, and in the next you can write question like this, taking cos x plus sin x common. What is this one? This is 1 plus log of sin x minus cos x. Now in the further next step, you can write dy upon dx is equal to shift the y to the right hand side. The value of y is, put the value of y, sin x minus cos x to the power same sin x minus cos x and into this whole statement, that is cos x plus sin x into 1 plus log of sin x minus cos x. This is the answer. Okay. Now come to the question number. That is question number, we will do question number 14. If you want to note the question, then you have to take the screenshot of the page and then note it down. Now come to the question number 14. It's a very good question. Question number 14. This is x root 1 plus y into root 1 plus x. Let's write question is x under the root 1 plus y plus sine y under the root 1 plus x is equal to 0. Then you have to show that dy upon dx is equal to minus 1 upon 1 plus x whole square, and the value of x is lying between minus 1 to 1. Now let's do the question. If you start this question directly, if you take derivative of the function, then it's difficult to find out the value of dy upon dx as it is given in the question. That is given minus 1 upon 1 plus x whole square, then that will be difficult to do question. In this question, you have to apply a technique to do question. So first of all, you have to transpose the second part of the statement to the right hand side. Now what is this? X under the root 1 plus y is equal to minus y under the root 1 plus x, like this. Now squaring both sides. Squaring both sides. What you will get? X square into 1 plus y is equal to y square into 1 plus x. Now you have to simplify it. X square plus x square y is equal to y square plus y square x. Now you will get, when you take the terms to the left hand side, you will arrange the statement like this. I think we can arrange the statement. Now this is what? X plus y and 2x minus y. Here in this part, you can take common x into y. If you want a factor common, that it comes out x minus y will be equal to 0. It is x squared, comes out x only, y squared left y. Okay. Now when you take common x minus y factor, which is lying in both terms, that is x plus y plus xy equal to 0. What it implies? Either x minus y equal to 0 or x plus y plus xy equal to 0. but x is not equal to y. So what? It means x plus y plus xy will be equal to 0. You can arrange this statement. You can arrange this statement like this. Suppose taking y common, this is 1 plus x. Take that x to the right hand side. And what is y? Minus x upon 1 plus x. This is the statement you will get. Now differentiate. You have now got the function in the form y is equal to fx. So differentiate the function now. Differentiate with respect to x. What you will get? Dy upon dx as it is, minus and taking common, apply u upon v algebra. That is 1 plus x whole square, 1 plus x as it is, the derivative of x, minus x as it is, the derivative of 1 plus x dash. What you will get? Minus, this is 1 plus x as it is because derivative of x is 1 with respect to x. This is minus of x as it is because derivative of x is 1 here again. 1 plus x whole square because derivative of 1 is 0 and x is 1. Okay, this you can cancel. What you will get? Minus of 1 upon 1 plus x whole square. And this is hence proved. You can do the question. It's very important in this question. You have to simplify the question first, then take the derivative of the function. But simplification is not so difficult, but this must be remembered to you. You have to simplify first, then do the question further. Okay. Now come to the question number next. That is question number. We will do question number 15 is not difficult. Just you have to try this question your own. Okay. Good question, but try your own. Now question number 16. Good question, question number 16. Let's do the question number 16 now. Question number 16. Question number 16 is, if cos of y is equal to x cos a plus y with cos a is not equal to plus minus 1. Condition is given, cos a is not equal to plus minus 1. You have to prove that dy upon dx is equal to cos square a plus y upon sine a. Cos square a plus y upon sine a. Here in this question, you can do the question in a 2-3 ways. But here I will do the question like this, just do. I have to just arrange the statement like this. X is equal to, write down x is equal to cos of y upon cos of a plus y. Now, in other questions, we do the differentiation with respect to x. Here I will differentiate this question with respect to y. Because this is a function where x is equal to f of a. In previous questions, we just write y is equal to f of x function. Here I have written x is equal to f of y function. So what? Differentiate the function with respect to y. Okay. What you will get? Dx upon dy is equal to u upon v. Application you have to apply. Algebra is cos square a plus y. Now cos of a plus y as it is, the derivative of cos y. I have to write down like this. Okay. Minus sign. And now cos y is as it is, the derivative of cos of a plus y. Like this. Okay. Now this becomes cos a plus y. Cos y's derivative is minus of sine y, because with respect to y we are moving, that's why it is minus sine y. There is no need to differentiate further. No chain rule will be applied here. Okay, minus sine y minus of cos y and derivative of cos a plus y, that is minus sine a plus y, and a derivative of a plus y is 1. A is 0, y is derivative is 1. Okay. Now this becomes upon, that is cos square a plus y. Now here the question, if you write this question with sign, let's just write down minus sine y cos of a plus y, this is a, minus and minus plus cos y sine a plus y. Now what is the formula which you have studied in the class 11th? Now tell me what I have to apply here. Now this is the formula, sine, you can write it like this, sine A cos B minus cos A sine B. What is the formula? Sine A minus B. Now write down what is sine A cos B minus cos A sine B. Okay, this is dx upon dy will be written like this, sine of, this is sine A plus y is A minus y upon cos square A plus y. Cancel these two y's, what you are getting? Dx upon dy is equal to sine A upon cos square A plus y. If you want dy upon dx, it means it will be the reciprocal of the previous one, that is cos square A plus y upon sine A. This is answer, or you can say hence proved. You can do the question. Now come to the question number, let's do question number 17. That I have done in the previous lecture, I think. You can do this question, no problem will be there. Question number 17, you do your own. In question number 18, I have just to guide to you, that is fx is equal to mod of x cube. You have to get the second derivative of the function. You know, if it is x is less than equal to 0, it will be minus of x cube. And if it is x greater than 0, then fx will be x cube. Like this you can write it. In the question number 18, in question number 18, just I have to put the idea. It is written fx is equal to mod of x cube. You can write it like this, x cube if it is x greater than equal to 0. It is minus x cube if x is less than 0. This is f of x. If you want f dash x, the derivative will be what? Same condition will be applied, 3x square and minus of 3x square greater than 0 and less than 0. If you want f of double dash x, second derivative, this will be 6x, this will be minus 6x square. Conditions are as it is. So, okay, you can do the question number 18. Now question number, I have to discuss question number 22. Question number 22. Let's discuss question number 22. Question number 22 is differentiate the determinant. And how to differentiate the determinant? Determinant is given f of x, g of x. Next is h of x. These are the element of the first row. Second two elements are L, M, and N. Third row elements are A, B, and C. Now, how to differentiate? You must know, you can differentiate the determinant by taking one row as u function, second v, and third is w. If you are differentiating first row, then other two rows are working as constant. If you are differentiating second row, it means you are taking others are as a constant. So like this, differentiate with respect to x. That is y dash will be equal to, just take u into v into w. It means you are differentiating first row. I have applied dash sign for the differentiation. Others are as it is. Algebra what says? Plus sign. Now first and third will be as it is. Third will be as it is, and you have to differentiate second. L, M, N are all constants, so derivative will be 0. Now first and second row will be as it is, and you have to differentiate third row. In third row, all constants are given, derivative is 0. So if any row having all elements 0, it means the value of that determinant will be equal to 0. So what? Then y dash will be equal to, f dash x, g dash x, h dash x in the first row, and l, m, n, a, b, c last row. Okay, other